Start the recording. All right, so welcome. This is ECE 264. My name is Dr. Vile. As a show of hands, how many people here are seniors or super seniors? Okay, about 10%. How many are juniors? 20 to 25%. Sophomores. Okay, that's a good third of the class. And freshmen. That's the other. Okay. Not sure if all of that adds up to a solid one, but we have a pretty diverse mix here. So I would encourage the underclassmen to find an upperclassman buddy. It's going to help you first understand when to laugh at my jokes and to understand that I am not, as my student reviews said last semester, angry and make fun of people who ask stupid questions. There are no stupid questions. Except for what Brad asked last semester. Those were always pretty rough. I come off as a hard ass a lot of the time, but if you come to me, I will treat you with kid gloves, give you what you need to succeed in the course. If you come to me at the end of the semester, and it's the first time I've seen you, I will treat you with kid gloves and give you exactly nothing. So, going around there, I'll highlight the changes that are wrong on this version of the syllabus. For some reason, it didn't sync to this laptop. This is ECE 264. It does meet here from 4 to 5, Monday, Wednesday, Friday. This is Library 207. And the labs are Monday, Wednesday, Friday, 12 to 2 in Seng 222, the nice classroom. I am Dr. Ben Vile. That is my email address. Your TA is Tim Chase, tchase at UMassD. He will be holding office hours either in 222 for sort of open lab, or you can find him for help in 211. The course description, you can read that just as well as I can, but we're going to be covering object-oriented. How many of you, this is your first programming course? Get out. You need to have 160 as a prerequisite, as it says right there. But I know that you're lying to me, because I know who you are. This is not an introductory programming course. This is a follow-on course adding to what you have already learned. How many people have taken more than 4 programming courses? How many people have taken more than 3 programming courses? How many have taken more than 2 programming courses? Okay. So you've all taken at least 1, most of you 2. Courses involving programming. We're going to be taking that procedural programming. Generally, what you start with is procedural. You start at point A, you do steps. Maybe there's ifs, maybe there's loops, but it's procedural. You can follow it through to the end of a program. And we're going to be dealing with object-oriented concepts. We'll get to what those are as we go on. But we're going to be doing it in a different language. We're going to be using C#. That symbol that looks like a tic-tac-toe is called a sharp or an octofork. There are no other except a pound sign is the only other acceptable thing to call that. It is not hashtag. You must have EC 160 at a bare minimum. This is the textbook. Allow. The textbook screen is available right here. It is extremely expensive at the cost of a button click. It was originally written by some Bulgarian folks who decided that they wanted to train people for their company so that they could get stuff done. I think that's a good tack to take with you guys. You want to get stuff done. So this takes an interesting approach. We are not going to be covering every chapter in this because this was designed to take someone who can't program at all and make them into competent coders in an object-oriented language. So there's the ISBN. You can purchase a hard copy of the book. It's like $30 from Amazon, 35 maybe. Not required, only if you want it as a reference. And the website has tons and tons of stuff, including all the slides that I will be using over the course of the semester. We have a pretty simple grading rubric. 3 exams worth 40%. That means that roughly each exam is worth 40 divided by 3. You're going to have labs and homeworks, generally 1 sort of assignment per week. in addition to your labs. And you'll have a final group project. We'll be doing those in groups of 3 or 4, where you'll be dealing with a text-based adventure game and dealing with object-oriented concepts. We will hit that. I think I've got that planned for after spring break to sort of introduce to that. We have to get some concepts under our belt before we can really approach that kind of a project. Any questions so far? What are your questions so far? I am Vile. That is the textbook. You have to know kind of how to program to be here. These are wrong. However, the ones on this piece of paper are correct. You'll notice that actually if you compare, there's only like a difference of 2 days. All of the days of the week are the same. The university schedule hasn't really changed for a decade or more. But the dates of the exams are already predefined for you. They're going to be on the 21st of February, the 20th of March, and the last, or the almost last day of class, April 27th. Okay. They are around. So can you just, who's got the extra syllabus? All right. So they're all there. You'll notice that exam 1 and 2 are on Fridays. That's convenient because these are take-home exams. Everyone can have a small cheer at that. They're take-home. Yes, and now people who might have taken this course last year, tell them how wrong they are. If a class is canceled before the review day, we'll do the review day on the next time the class meets, and then we'll do the exam. The day that we actually do the exam, all we are going to do is shove out the exams to everybody. We'll talk about Git in a second and how we're going to administer those exams. So if anything is canceled, everything shifts by 1 class. If you miss an exam for some reason, which it's hard to miss a take-home exam because you take it home, you can be wherever you want to be. But if you miss it for some reason, you're in the hospital, you're sick, whatever, we'll do 1 in-class make-up exam, and that's scheduled for the last day of class, April 29th. If you don't miss an exam, you don't have to show up on the last day of class. You can devote your time to other more pressing matters. Attendance is not required, but lab attendance is mandatory. You got to show up to lab, do the stuff in lab as asked. All right. This is a small section entitled Academic Dishonesty. You are getting a lot of leeway. For the seniors, you understand what leeway is. For the freshmen, you might not understand what is acceptable behavior in the case of a programming course. Working together in certain contexts is okay. On an exam, it is not okay. On a homework, in general terms, you can talk about the problem statement. You cannot share code between one another. All of your assignments automatically get sent through something called MOS. MOS stands for Measure of Source Code Similarity. If you've ever tried to copy off of someone else, you know that you should do things like change the white space around and change the variable name so that it looks a little different, but it's, it still works the same. MOS basically sees through that stuff. It turns everything into tokens that it basically compares on a lexical basis. You're not going to fool it, is the point. So don't, because then, well, those 2 bullet points sum it up. You cheat on a homework, you get an F for that assignment. And homeworks are 40% of your grade. You really can't afford to take an F on an assignment. Where were we? If you cheat on an exam, you're just gone. Thanks for playing. Come back next year. Bye. I don't want to hear it after that. There are very few things that I get serious about. Cheating is one of them. In conclusion, don't cheat. This is the written homework policy, which doesn't really apply to you, but if I do assign some sort of written homework, make it clear and legible, put your name at the top of it, things like that. Everything we do in this class is going to be submitted through Git and GitHub, which towards the end of class today we're going to start talking about. If you are having trouble with this course, there are several resources that are available to you. The first resource, me. I have office hours. My door is almost always open. Come on by. Okay, I'm very approachable, usually if I've had my coffee. So come on by, we can talk about anything you want. Doesn't have to be necessarily the course, it could be advising, it could be whatever you want. Second resource, the TA, room 211, Tim Chase, reasonably okay human. Unless you're his group member, Julia. So third resource, the Tutoring Center. Does anybody not know where the Tutoring Center is? Science Engineering 217, keep walking that way until you hit the plants, and you will get there. And finally, if you have any anything that needs to go through Center for Access and Success, you probably already know about this. Just come by with some papers and I sign it, and we can take care of that. It's in Pinedale 7136, last time I checked. All right, that's the syllabus. I don't have a day-to-day topic list because this is, while it is the second time I've gone through this course, I'm still sort of massaging how I want things. So I have a plan in the back of my head about how things are going to go, but I reserve the right to kind of play around with that. Whatever we get to at the date of the exam, that'll be what we cover. Okay, and we're going to start right now. Introducing C# and console input and output. We're still going to be dealing with the console. So if you took 160 here, and you use the console for every project, this is not the right thing. Better. Okay. Console input and output. How do you actually start interacting with the console in the context of C#? I don't feel bad starting on chapter 4 of the book without giving you any of the underlying things, because C#, 80% looks exactly like C. So if you've had C, which is a prerequisite for this course, you should be okay. We're going to cover how to get something out printed to the console, and then we're going to cover how to get things in from the user into variables. We'll have some examples as well. So printing to the console, this is a console window. Anybody not familiar with a console window? Okay, where did you do your programming the last time you took a programming course? What language did you use? Java, okay. Did you have to do, were you doing like swing applets, or were you doing text-based entry? Okay, so the console is just where you type that text and where text appears to you. So when you do java.print or whatever, console.println, okay, you're actually going to see a lot of similarities to C#, because C# sort of this unholy love child between Java and C. So it's just where you type things, okay, and where things come out. So this is an example of a run of a program, and as a convention, we say when we print something out and ask for something, so here enter a person name, colon, the stuff that's typed after that looks the same. Ooh, my hands are a little shaky today. But those are user-provided input, whereas that is programmer-provided output. You can't tell the difference on the console, but as we run through things, you'll get that. Now, this is a pretty simple program. It asks for a name and a company name. That, by the way, is one of the authors of the book, and that is the company that published the book. And it creates this form letter, effectively a mail merge. But it's formatted output. There's spacing involved. It puts things where it needs to be. It's a little bit easier than C, because in C you had these format specifiers, %D, %F, %8.20F. We're not dealing with that today. The console just displays information. It can display strings, numbers. C# doesn't really care what you want to display. C# is an object-oriented language, meaning that when you have an object, like an int or a string, it is smart enough to figure out how to get the appropriate characters to the console to be displayed in a user-friendly way. And everything is going to go through this thing called console. The console is that box that we just had, okay? But the console itself is an object that you can manipulate. So instead, what were the main ways of interacting with a console in C? There were two functions that we used. F.print. Close. printf and its corresponding scanf. Okay. In this case, everything goes through this thing called the console. Okay. Console has a bunch of commands that you can tell it what to do. Things like read, things like write. A helpful extra one is write line, which is the same as write, but it puts a new line at the end of that argument. So whatever you put in those parentheses is what's going to get printed out on the screen. So that first line right there, int a equals 15, might as well be a C statement. Actually, it could be a Java statement too, I suppose. Where's that mouse? Get out of it. If you want to print any variable, you can say console.write, and whatever you put inside those parentheses will appear on the console. You can do more interesting things with formatted code. Those squiggly zeros, squiggly 1, squiggly 2, those all are placeholders. We'll talk about how you manipulate those. But it's possible to make things print out in a very nice way. And it doesn't really matter if it's an integer, a double. Notice there's nothing here that specifies what data type it is, 0, 1, 2. Those are just positional. Whatever the 0th argument is, whatever the first argument is, whatever the second argument is. And write is actually pretty nice in that you can put expressions. So this is just a function. It's a function called write, and it takes in some arguments. Not dissimilar to printf, but with a few syntactical differences. In this case, it does make a note that write is what you would do if you didn't want to go to the next line. Write line will automatically append a new line. As a sanity check, what if you had to use the write function for some arbitrary and capricious reason, like I said so, and you wanted it to go to the next line? What could you put inside of a string to cause the console to go next line? A \n, yes. So all this stuff that you've already learned is still applicable in C#. And you're going to hear that a lot the first few weeks. Is that most of what you know already applies. Except for this, right? I love lying to you and then telling you how I've lied to you. There is no such thing as a string in C. If you wanted a string, what did you have to do? What did you have to use? Right? Plus? That won't work in C. Who said that? What? A character array. You had to use a contiguous block of RAM to hold individual bytes and then treat them sort of special. Not so in C#. C# is easier because it has a dedicated string type. Just takes care of everything for you. You don't have to worry about bounds checking. You can even add to strings. But as far as C# is concerned, a string might as well be an int or a float or a double. It's a basic data type. And so if you want to use strings in a formatted example here, there's that squiggly 0 is going to put whatever's in name, and the squiggly 1 is going to put whatever's in year. It does not care what the data types are. Name could be any data type. Okay? It's smart enough to understand how to convert name into a sequence of characters. For a string, that's kind of easy. It takes the H, the E, the L, actually, wrong example, M-A-R-R-Y, and it prints it out one character after another. Then it prints was born in, and then it prints 1987, the characters 1987. So if you remember your ASCII code, ASCII for a 1, the character 1, is 31 hex. 9 is 39 hex, so on and so forth. What's the ASCII code for a capital A? Interesting. Yes, it is decimal 65. In hex, it's 41. All right, 41 and 61 for upper and lower case. Yes, 65. Okay, so putting all of this together, here's an example snippet of code. We're actually going to run this right now and run through it. But all we're doing is declaring some variables, and we're using the console.write or write line function. All right, and what is this going to do? It's going to print out Peter is 18 and from Sofia. Sofia is this, by the way, I said was written by a bunch of Bulgarians. You're going to see a lot of very specific names. Chances are it's a local town in Bulgaria or something. So Peter is from Sofia, which doesn't mean that Sofia is his mom. It's a town. We're also going to let's do these one at a time, actually. All right, let's screen. Okay, so can you read this font size? Let's set this. If you need it to go bigger, just shout out that you need bigger. So, starting at the very top, the structure is similar to how a C program would work. In C, the first lines usually include standard I/O. Standard I/O is there to give you the basic functionality, things like printf and scanf. System is the equivalent, so we're using system. When you start a new project, everything's going to be enclosed in this class. All of this is boilerplate code. As you see, when we start a new project, you're going to get a lot of pre-made code that you're going to use. But for our purposes, everything starts with void main, just like C. Okay? Main is the main function. There's some extra things, and I'm intentionally jumping into the middle of this. I want to get you up and running as much as possible, and then start applying concepts you already know, and then add on to those concepts. So a couple of things to note. When you are using Visual Studio, which is what we will be using, I'm using 2017. In lab, I think we're using 2019, but it's not going to change. Anything that is a keyword will be highlighted blue. Strings are highlighted in sort of orange. Keywords are a light green. Those are class names. And then comments are the dark green. So here is the first example. It is code. We can run this the same as we could when we did C in 160. Start debugging, it'll go. And it's going to give me something that's completely unhelpful, but it will give me a console. In this case, this console is running the wrong demo. We can close and run the right demo. It went too fast. So my computer, we've noticed, is a little slow. That's good. Okay, is this font too small to read? Too small to read, okay. Font, 36. Better? Okay. So nothing really interesting here. Peter's 18 years old from Sofia. This is on the same line. Next sentence will be on a new line. Bye-bye, Peter from Sofia. You can take these basic building blocks and start making much more complicated output decisions. A lot of what we're going to be doing in this course is designing a specification for the output of a program, and you're going to have to match that specification exactly. Whether it's the correct number of spaces, tabs, the correct number of decimal points, you have to match it exactly. Because what we're going to be dealing with most of the class is automated testing. How many people, when you were writing code in some other class, would write a loop or some function, and then you would run the program, you'd type in 3 or 4 numbers, hit enter, and then look at the result and find that it was the wrong result or the program crashed. So you'd make some changes, you'd rerun the program, you'd type those same 3 or 4 numbers, and then look at the output again. That was your development cycle. Okay? How many people get tired of typing those 3 or 4 numbers? Okay. Yeah, that's not the way we do it. Our time is more valuable. Okay, and it gets harder because if you are making larger and larger applications, you're going to have lots of little pieces that all need to stay working. And so we're going to be dealing with automated testing. Automated testing is the idea that you write a bunch of tests and you keep adding to those tests over the lifespan of your application, the development application. And they are always running. Every time you make a change, run all the tests. That way, if you make a change that accidentally breaks something that should be, like not really related to what you're doing, you will catch it immediately. And if you catch it immediately, it'll be a lot easier to fix. Whereas if you only notice 2 weeks after you make the change that something in application part 4.2.7b is broken, well, what was the change that actually caused that to break? Okay. So, go back one. The takeaway, this first example, and again, these are all on the M Drive and they're all on the website. You can download them and run them yourself. Any variable type can be supplied to console.write. All you have to do is provide a placeholder, 0, 1, 2, in squiggly brackets, and that placeholder will take whatever the positional argument is and convert it to text and merge it. Question? Okay. If there is a question, you can interrupt me, and that's fine. I'd much rather people talk to me than me stand here talking for an hour. Okay. So let's add on to the complexity here. Printing things like 2 plus 3 is 5 is all well and good. But if you start dealing with more complicated numbers, like pi, 3.1415926, that's wrong. It's 3.14159266535. Right? Typo. If you didn't have the right kind of display, you might not catch that those last few digits were wrong. In this case, I've used some extra schmutz to cause that floating point variable to change how it's outputted by providing some modifiers. In this case, by putting a colon and then stuff, I can change how something's going to be displayed. In this case, F means it's a floating point number, and the 2 means I want 2 decimal places. Other than that, you're just passing pi. Now, if pi is not a floating point number, things start to get a little strange. But if you match these up, you will end up with 3.14, as opposed to 3.14159266535. There is one thing that's a little strange about the comment on that line. Anything look strange about the comment, Jeff? It is a comma. Where are the authors from? What is the decimal point character in Bulgaria? Well done. It is a comma. In C#, the console.write line application is smart enough to know what locale you are in and will use the correct character for your locale. Even for things like currency. If your currency is the US dollar, you get the dollar sign. If it is the pound, you will get that L-looking thing, which I assume is the pound symbol, but not the octothorpe. Different pound symbol. All right. Double string, Fanta. Okay, let's run a few of these. These are all just designed to highlight some of the things that can occur when you are... Oh, I didn't want to do that. Hit the wrong button. I do want to know why it's taking so long to kind of get its act in gear. Okay. So here, that is the output from those numerical things. Let's look at exactly how we've set that up. So here's our Peter and Sophia. We've dealt with that. Here is a double. A double variable has some amount of decimal precision. but we've used 3 decimal places, 1.234. We can actually provide a format specifier saying I want this many digits. So instead of saying F2 or F6, we can just say that. Now, I'm only covering a fraction of these. It is up to you guys, as needed, to go to the documentation for these things, which I believe on my machine, if I hit F1, it actually brings me to the Microsoft Developer Network website. It actually looks up, especially if the network is working. It says it's working. Better. Okay. The developer note. This is the home page for any documentation on what's called the .NET framework. That's all the good stuff in C#. So if you want to look up console.writeLine, here's the method, console.writeLine. Tells you every way that you can use it. There's quite a few different versions of WriteLine. String, object, object. Just writing out single integers. This is the good one. Here is some examples of all the different things that you can print. Currency, decimal numbers, scientific notation, fixed point notation. That F with 2 decimal places after it, fixed point. General, numeric, percentage, round trip. I don't know what round trip is. Hexadecimal, if you want to print in hex. You can even print more complicated data types, like a date. Okay. It goes on at some length. So the docs.microsoft or the MSDN, Microsoft Developer Network, is where you would go to get the help on these things for specific use cases. For now, it is enough to know that if you have a positional specifier, 0, 1, 2, 3, and you append a colon and something else, it will modify the variable's display. So here we're actually saying that we want this many decimal places, which is why when we print 1, 2, 3, 4, we get an extra 3 decimal places. Keeps everything nice and aligned. There's our display for pi, and we do it in a slightly different way. We say, we want to use 4 places, pi and ben. This is obviously a modification because I'm creative with my variable names. So there's pi. D7 is just another way of aligning your outputs. In this case, we're saying use it as a number, 7 positions, but it's 7. The number 7 doesn't have 7 positions. In this case, we're right aligning. We can left align, we can right align. I don't think there's a center. Okay. All of these are options for how you're going to be displaying. Oops, one more. Displaying things. Okay, I don't want to go too much more than that. I want to get to reading from the console. For the start and for most of the semester, we're really only going to be handling getting in strings and getting in numeric data types. It's really not, yes, question. Can I close? Well, what is that? Wait. See, look, if I keep going, it appears on the side. Because this is my second monitor. So that's extra complicated. Okay. Let's rewind back to C, ECE 160. What was the command to get user input? Scanf, right. And when we use scanf, we could ask it for different data types, right? We could ask it for ints with %d, floats with %f, and it was smart enough to understand that a float had a decimal point in it, and it would automatically align those characters that you typed in. Because remember, you are just pressing keys on a keyboard. and it would turn that into an IEEE floating point number. With strings, it would accept characters up until what? How did it know you were done entering characters? You hit big button, right side of the keyboard. Enter. You hit enter. Console is no different here. Hitting enter generally signifies the end of input. But C#, even though it's a higher level language, it's got more bells and whistles, is actually a little dumber when it comes to input. Mostly because it deals with graphical user interfaces and things like that. But when you're dealing with the console, it really only asks for strings. That's all it knows how to do. So the next couple of slides are how do we take strings and turn them into other data types. So when we read, we can really only read characters and strings. If you want numeric types, you have to convert those strings into some kind of integer. So there's two functions you need to know, read and read line. 90% of the time, read line is going to be what you want. You're going to read in a line of data. When you hit enter, you then interpret that string as some other kind of data type. If you use read, that just gets a single character, but that's not super useful. So read, yeah, gets a single character, but it does it in a bit of an interesting way. It actually returns an integer. You have to cast by using the variable type char in parentheses, that to a character. So the integer I actually returns even more information, but it returns it as a 32-bit integer. So the ASCII code takes up how many bits? $32 bits, 64 bits, 5 bits, a shave and a haircut, 2 bits, 8 bits, 16 bits. One of those was the correct answer, yes. It's 8 bits. 7 if you're being pedantic. Technically ASCII is only 7 bits, but extended ASCII is 8 bits. So if there's nothing on the keyboard, it actually returns -1 in 32 bits. What does -1 as a 32-bit unsigned integer really look like? If you've taken 263, you should be intimately familiar with signed versus unsigned numbers. Well, let's do it another way. -1 on the number line is 1 to the left of 0. Everybody agree with me there? Okay. If you are on a car odometer and you go forward from 0, you get 1. If you go backwards from 0, what do you get? No, like if you break it, if you illegally roll back your odometer. $9.99. There's no -1 on a car odometer because nobody expects you to drive negative miles. There was a great Married with Children episode where Al Bundy tries to drive backwards to get his odometer back, but it doesn't work. Sorry, spoilers. Do you guys know who Al Bundy is, Married with Children? A few of you. I digress. Where were we? 9999. We get 9999 because each wheel is a circle. If you go backwards from 0, you end up at the highest number. You don't end up at negative numbers. So a -1 as a 32-bit unsigned integer is actually all ones. F, 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 F. Why is that important? No, null is actually 0, and in C# we don't even have anything called null. That's a different problem. Because what would happen if you cast a -1, which would be all F, as a character? You take those lower 8 bits, what would that become as an 8-bit integer? Take 32 bits of 1s, you chop it down to 8 bits of 1s. 8 bits of 1s in hex is FF. So if you're casting these things that you see an FF, You need to understand what that really means. It's not saying that somebody typed in a key that corresponded to FF. That's not really an ASCII character. It means there was nothing there. Okay. So that's one option. I'm not going to do the character one because I want to get to the, I don't want to do read key. I want to get to read line. Read line is where things start to get interesting. Read line returns a string. So this starts to get towards where we started with that first console. Enter your name, enter your company name. Using read line, it takes whatever you type up until the point where you hit a carriage return or a return. Null is what happens if there's nothing there. Null is not 0 in the context that it used to be. Null in C was a define that just happened to be defined as the number 0, specifically an address. Null is an actual object. It means something. It's not 0, it's null. It's not nothing, it's null. It's a specific thing. It's important to the language of C#. It's a null. But it returns a string. So for things like mail merges, last names, first names, this is great. You can say, hello, so-and-so. This is worth doing a little bit of a demo. Okay? When you are inputting things, reading strings, this is the same code we just had up there. It's printing some things out to the console, and it's reading things from the console. Run it. And this time, it's not just going to display stuff and disappear. It's going to sit here waiting. That blinking cursor is saying, hey, I'm waiting for some output. Some of this should be reviewed. But if I type, enter your first name. Come on. Amazing. We're coding here, people. I know, it's not the most glamorous stuff, but we're going to build on it. By the way, this press any key to continue is not part of the program. It's part of Visual Studio. It gets stuck in there so that your input doesn't go away. We're back. Okay. So, the hard part is coming up. How do we get numbers in? It was actually easier in C, a low-level language, arguably low-level language, to get integers because there was a built-in scanf that would get us integers, and it would put it into an integer data type. In C#, there's no such thing. It's a multi-step process. First, you get in a string, then you convert the string to the data type you care about. You can do that with a function called parse. Parse is actually part of this thing called int. Int now has things that it can do. It's not just a data type. You put a dot after int, you can actually do a lot of things. In fact, let me just show you quickly. If I type, yeah, you can see that. If I type int dot, there's actually a few things that you can do here. I don't know if I can actually make this work. But you can ask about its maximum value, its minimum value. Parse allows us to convert strings to integers. So if you give int.parse as an argument a string, which itself is characters from 0 to 9, it will turn that into an integer. If I had changed this code snippet here, instead of saying you enter squiggly 0 number to you enter squiggly string, 9 times out of 10 that input is going to look the same because you're typing in 1, 2, 3, and if you print the characters 1, 2, 3, that's the same as printing the string representation of the integer 123. But not in all cases. Let's skip right to the demo. Reading numbers. So here we're going to say, hey, give me a number A. We're going to parse that string We're going to say, give me a number B. We're going to parse that string, and then we're going to print out the plus and the sum and the product of those two numbers. And finally, we're going to ask for F, and we're going to do a few more things. So as I run this, A, 12, B, 10. Now, as far as you know, the left side of those assignments could have just been strings. I could have just taken the string A and the string B and printed them out. Where it starts to get a little more interesting is if I do this. It actually took that 0, 1, 2, the characters 0, 1, and 2, and turned it into the integer 12. So when I print it, it doesn't need to print a leading 0 because that's superfluous, right? I could add zeros to the beginning of a number all day long. So in this case, I'm multiplying by 12 and then dividing by 12. Let's run that one more time with 3 unique numbers, 12, 10, and 6. And you can see what it's doing here. Now, all I'm doing is taking in input, converting it to an integer, and then printing it out. There's nothing really rocket science. In fact, you can do the same thing in C without too much difficulty. The difference is, when I do that, things start to go off the rails. This is what's known as an exception. We are not going to be able to handle exceptions for quite some time, so we really want to avoid them for the foreseeable future. But this is an unhandled exception of a type format exception. The input string was not in the correct format. Well, of course it's not, because I am not aware of any number called Ben. Well, actually, I'm a perfect 10, but... See, you're learning when to laugh at the jokes. This is good. Specifically, there's some information about where this badness occurred. In this case, it's on line 10. Line 10 is the thing that really broke the camel's back. If I look at line 10, it's this call to parse. Integer does not understand how to turn Ben into 10, because it's not a number, exactly. So it dies. It just throws up on you and says, sorry, and it doesn't even continue running the rest of the program. It just gives up. In some ways, this is a good thing, because at least it gives us some feedback as opposed to just dying. And reading this is a skill. You have to be able to go through and say, all right, this is the thing that really died, but that was called by this thing, which was called by this line, and this is the line I wrote. There's a lot of code that's running that you didn't write. It's part of the .NET Core. So what we're going to do instead, and we'll get to this. Let's see here. We've done our demo. Parse, floating empty. We've done that. There are more than one way to skin a cat. You can use the convert class, but no point. Does the same thing. We've done the live demo. Here is the better way to get an integer. It's called try parse. It does require a bit more code, some scaffolding, but it guarantees that you will not throw an exception. It's not guaranteed to always get a number, because as we've already established, somebody could type in Ben, but it will give you some feedback. So if you say try parse, you've got to do a couple of things. First off, this is still part of the int object, so you say int.tryparse, and you have to provide 2 arguments. The first is the same thing, the string that you want to deal with. The second thing is you have to say the word out, it's a keyword, just like console and just like if, it's a keyword out, and you say out, and then you provide a variable that is an integer. So number is an integer variable, and tryparse returns either true or false. C# is a little bit different from C in that there is actually a variable type of Boolean. Boolean meaning either true or false, 0 or 1, but it's an actual data type. So if tryparse is successful, it returns true, and you are guaranteed to have an integer in number. If it is not true, That means that the result in number is garbage. You can't trust it, you can't use it. So you can test that result. I don't recommend doing what they did here and nesting it inside of this call to if. Okay? Assign it to a variable and then test the variable, because you can do a few more things with it. It'll stay alive in your scope a little longer. So try catch blocks are still a few weeks off. We can use try parse. So here's the code. If we run this code now, it still works the same way for numbers. If I type in 234, it says it's a valid number. It knows that try parse returned true because it was successful in parsing this. If I type in 0123, still a valid number. If I type in Ben, try parse fails, but it does not crash. It does not throw an exception. It just gives up. It says, nah, I don't feel like it. We'll go on. There's more than one way to make this program crash, however. We know that if we type in a number like 123, it says valid number. But if I type in a number like 8 billion, it says it's an invalid number. Why? Why is 8 billion an invalid number? It's not even that big. It's like, but what's, yeah, no, you. Well, we still haven't left the idea that we have resource constraints. You're right. It's not so much that it's a signed integer. It's that it's a 32-bit signed integer. A 32 bits. What's 2 to the 32? It's roughly 4 billion. The 2 is enough to tell you that it's 4. 2 to the 2 is 4. 2 to the 30 is a giga, or a billion. So it's roughly 4 billion. Okay, I don't know the exact number. So I went way over 4 billion. In fact, I think if I had said 3 billion, it would have died too. 3 billion, no good. But 2 billion, valid. Because 2 billion is under that 32-bit signed integer cap. Okay. That's where we'll cut it for today. Stop. Homework. Go to github.com. Make an account. github.com. Make an account. Your labs will begin on Monday, and you will need a GitHub account to do the lab. It will not really involve any programming much. It will involve using GitHub. Can I have the extra syllabi brought up here, please? And I got to remember to stop this. You can't have that one. Get one with a staple. Just wait for the ones with a staple.